This is the mystery machine. It's not very big, you can see by my hand, and actually the little armature in there is maybe the size of a small orange, like a tangerine or something. I've had this for several years. I found it on eBay and I saw the picture, could see the two collector rings in there, and so I knew it would be interesting. I figured if nothing else, it was a small AC generator. It's got a pretty good sized shaft on it for the for what it is, and indeed it does have a little commutator down in there that you can't see, and I have spun it up with a drill motor, and it'll light up a light bulb off those collector rings. Let's see, it's 2-pole, so if it was going to be a 60 cycle machine, obviously it would have to run 3600 RPM. And so tonight I thought, well, let's run it up as a shunt motor. These are the DC connections here, obviously the AC connections here. These terminals here are actually the brushes, the DC brushes, and the field connections are there. I almost want to say you could almost reverse the rotation. I don't know if they'd reach to the other side or not. I had it apart when I got it, but it was a long time ago. Anyway, the field is a little over a kilo ohm, and experimentally here we can, well, let's back up here a little bit. I was going to say we can start it up. I've got a bridge rectifier here, and we have a variac here, 120 volt variac. Another thing, that's right, the collector rings are not tied to a separate winding like an AC generator would have. They are simply tapped off of the DC winding, which would make for terrible voltage regulation on an AC generator, which kind of makes you wonder about what was the purpose of this thing originally. But it also means that to get 120 volts off of those collector rings AC, you have to give it about 170 volts DC. My 230 volt variac is not handy at all. And the other thing it means, oh man, this is so getting too much. Anyway, so what I've done is this transformer here has 4 120 volt windings in it. I've got one of them connected to the line. We can go over here and plug that in. Alright, so now we got 3 other sources of 120 volts. These two are tied together in a 120-240 arrangement. The little variac is across 120 volts. So basically my variac now can go between 120 and 240. So that's the DC voltage I can give. So we're turned all the way down. This switch applies the DC. The brushes are a little squeaky in it. And then I can turn it up from 120 volts and go all the way up to 240 volts. Commutator gets a little sparky at that high voltage, so I don't think it's designed to run at 240 volts. But indeed, when you get this up to around 170 volts DC, you get 120 volts AC out of those collector rings. And I thought, great, now I want to try to parallel it to the line. So my other 120 volt unused winding, which is isolated, is tied over here to this switch, and across the switch is those two 130 volt 15 watt bulbs in series. I was going to use them as synchronizing lamps. So I turned that on, and yeah, you can see in the video those are flickery. Well, the flickering in the video is different than the flickering of the lamps, but they're visibly flickery. And we can turn this up. You can also hear the phasing because our DC supply is pulsed. And you can reach a speed where it sounds like it's running at synchronous speed. Let's see, where is that? Right there. But the lights are flickering like crazy. At this speed, without those bulbs on there, you're getting about 120 volts out of it. But I think that's about 1800 RPM. There's no way that's running 3600 RPM. I mean, just listen to it. So, what on earth was this thing originally for? You know, it runs great as a DC motor, but it would put out, you know, at 120 volts DC, you get about 80 volts AC out of it, necessarily because of the ratio of the square root of 2. And a weird frequency. I don't even know what frequency it ends up. If you drove it at this speed from a DC motor, you know, well, then you'd be getting a DC motor, an AC motor, like an 1800 RPM motor, you'd be getting 30 cycles per second out of it, and about 120 volts. What is that for? Telephone ringers? I don't know, man. There's no nameplate on it, no identification at all. Hence, it is a mystery machine. It's obviously upside down right now. This is its base. I don't know. Don't know what else to say. Obviously, I never could throw my paralleling switch because I can't get it up to 3600 RPM. I even reconnected this so that I had a range from 240 to 360 volts on the Variac, thinking maybe it was a 240 volt DC device, like from, 240 volt AC, like from Europe or something, and maybe you'd get to 50 cycles and 3000 RPM. But when you get up to 300 and something volts, you start getting a lot of sparking. See, even there, we're getting sparking on that commutator. I think it's, I bet this thing is designed for, 115 volt DC. No sparking, well, almost no sparking. It needs to be cleaned up. I'm sure if I serviced the commutator and everything, it wouldn't be sparking. But it's a real slow running machine at 120 volts DC. Also, if it was, like for instance, if you had 240 volts DC across it, that field, that kilo ohm field is dissipating like, 55 watts or something. It's like, well, that wouldn't last long at all. At this rate, the field is something like, 15 watts or not even that much, something like that. I did the math earlier. So anyway, yeah, let me know. I wish I could have shown a video of syncing it up to the line and running it as a synchronous motor, and then I was going to shut off the DC and let it run. It would be basically a synchronous converter at that point. But it does work as a rotary inverter and a DC motor. Man, what's it for? Pretty weird. Thanks for watching.